Welcome to AIMS University, Malaysia. This is Dr. Sridevi here. Today's topic is Metamerism and Tautomerism. Coming to the definition. What is metamerism? This is a type of isomerism which is due to the unequal distribution of carbon atoms on either side of the functional group. Members of this metamerism belong to same homologous race. The metamerism arises when different alkyl groups are attached to the same functional group. Coming to the example, the following are the metamers that contain ether functional group. However, they differ by the nature of alkyl groups attached to the oxygen atom. The first example is diethyl ether. The other one is methyl propyl ether. Third one is isopropyl methyl ether. All these belong to the example of metamers. Metamerism is also possible in amines. Now we can see the second example of amines exhibiting the metamerism. There are three amines: diethyl amine, methyl propyl amine, isopropyl methyl amine. These three are good examples of metamerism. Here we can see there is an unequal distribution of carbon atoms on either side of amine functional group. Coming to other topic, tautomerism. This is a special type of functional isomerism in which the isomers are in dynamic equilibrium with each other. Tautomers are the structural isomers of the same chemical substance that are spontaneously interconvert with each other, even when they are pure. They have different chemical properties and consequently distinct reaction and distinct reaction characteristics to each form are observed. If the interconversion reaction is fast enough, tautomers cannot be isolated from each other. Here in this slide you can see there is a dynamic equilibrium between a keto form and an enol form exhibited by acetone. The left side is a ketone form which we call it as an acetone, and the right hand side is an enol form which is prop 1-ene-2-ol. An alcoholic group on C double bond C is called enol. It is alkene alcohol. The tautomers are formed due to complete transfer of hydrogen atom, and however the relative stable keto form exists in higher percentage than the enol form. It is very important to note that the tautomers are not the resonance structures of the same compound. However, the enol form is also stable in certain cases due to other stability factors. Here you can see an example of 1,3 dicarbonyl compounds like acetoacetic ester, which otherwise we call it as ethyl acetoacetic ester. It is an example when they differ by the position of a proton, such as keto-enol tautomerism, where the proton is alternatively on the carbon or oxygen. The left side is keto form and the right hand side is the enol form. It is an ethyl acetoacetate which is in equilibrium mixture with two forms, 93% of the keto form and the 6% of enol form. Enol form is more stable than the keto form in certain cases of phenols due to the stabilization by resonance in certain cases of aromatic structures. You can see the left hand enol form is more stable than the right hand side keto form, which is less stable. Now coming to the other example, nitroacetautomerism. It is exhibited by the nitro compounds containing at least one alpha hydrogen. In this case also, the hydrogen atom is transferred completely from one atom to the other during the conversion of nitro form to Ac form and vice versa. So here you can see nitroacetautomerism exhibited by nitromethane. The left hand side is a nitro form and the right hand side is ace form. By this, we come to the end of our topic Metamerism and Tautomerism. Thank you.